Welcome students, welcome to part 4 of chapter 2 structure of atom. In the last video we have discussed about Rutherford model of atom and continue with that part already. So as we discussed about the Rutherford model of atom, it tells us about the various terms related to the atom. The very first is the atomic number. So atomic number, that is represented as the capital letter Z. It is defined as the number of protons present in the nucleus of an atom. For example, if suppose this is an atom and it is a nucleus, so as the Rutherford model tells that inside the nucleus we have the number of neutrons along with the number of protons. So the number of protons present inside the nucleus of an atom is called the atomic number, represented as Z. So we can say Z equals to the number of protons present in an atom. As the various models of atom suggest that an atom is electrically neutral, so it can also be said that the number of protons are always equal to the number of electrons in an electrically neutral atom. So you can say the atomic number is also said in terms of electrons is equal to the number of electrons present around the nucleus of an atom. So this is what the atomic number Z. For example, if we are talking about hydrogen atom, so hydrogen atom having the atomic number as 1 because one proton is present inside the nucleus of this atom. If we talk about the chlorine, that is atomic number as 17, so it consisting of 17 proton in its nucleus. So this is what the atomic number. The next term is mass number. So mass number is defined as the sum of the number of protons and the number of neutrons present in the nucleus of an atom. As I told you that inside the nucleus, two subatomic particles are present, that is neutrons along with the protons. So the sum of these two entities is termed as the mass number, which is represented by capital letter A, that is mass number. So we can say that the mass number is equals to the sum of number of neutrons along with the sum of number of protons. This is what the mass number. For example, if I am talking about helium atom having the atom number 2 and mass number is 4. So this 4 is equal to, that is A, and this is taken as the Z. Z is atomic number and A is the mass number. So in this A, mass number 4 it means what? There is 2 protons and 2 neutrons are present in the nucleus of this helium atom. In case of nitrogen, having the atom number 7 and 14 as mass number, so the mass number it has 7 protons and 7 neutrons present in the nucleus of a nitrogen atom. So this is what the mass number. The next term is the isobars. So isobars are the atoms with same atomic number but different mass number. So various atoms we have showing the same mass number but different atomic number. For example, if we are taking example of argon, that is mass atomic number as 18, and calcium atomic number as 18, but one of the isotope of argon having mass number as 40 and the calcium also have mass number 40, and one more atom that is potassium, it is atomic number is 20 and the atomic number is 19 but mass number is 40. So these three are the three different atoms having the different atomic numbers but having the same mass number. So these three are called as isobars to each other, means the same with the same mass number, that is 40 in each case, and different atomic number, that is 18, 19 and 20. So this is what an example of isobars, the identities which having the same mass number and different atomic number. The next term is isotopes. So the atoms with same atomic number but different mass numbers are termed as the isotopes. In case of isotopes, if we are taking example of isotopes, that is hydrogen having 3 isotopic form, having the same atomic number, that is 1 to each, and showing the different mass number, that is 1, 2 and 3. So these 3, it is called as the protium, it is called as deuterium, and it is called as tritium. It may be also written as hydrogen, that is protium 1 1, that is deuterium 1 2 and tritium 1 3. So basically these 3 isotopes of hydrogen show a different mass number due to the presence of different number of neutrons in them. For example, if we take atomic number of hydrogen, that is 1 in each case, so it consisting of 1 proton in each. As we know, the number of protons are also equals to the number of protons is also equals to number of electrons. So the number of electrons present are same, but there may be the difference of number of neutrons in them. So in case of these 3 isotopes, there are different number of neutrons in them. So this is what the 3 isotopes of hydrogen. If we talk about one example, that is chlorine. So it's showing us two isotopes, that is chlorine having some atomic number as 17, but mass number is different, that is 35 and 37. As I told you, the potassium, that is K1938 and K1939 and K1940. So these 3 are the isotopes of potassium. So we have the lot more isotopes along with the argon and various isotopes we are having. So this is what an example of isotopes. Now the third identity is, that is the isotones. Isotones are the different elements having the same number of neutrons in them. For example, if we are taking as the definition of isotones showing the same number of neutrons but of different elements. So this is the definition of isotones showing the same number of neutrons. For example, if we are talking about example of carbon, nitrogen and oxygen having the atomic number as 6, 7 and 8, but one more isotope of carbon is 14, isotope of nitrogen is 15 and isotope of oxygen is 16. So we have the 3 different elements, that's carbon, nitrogen and oxygen. We need to first of all find out the number of neutrons present in them. Do they all are having same number of neutrons? So as we know, this is called as A, means mass number, that is equals to sum of neutrons along with the protons. So if we wish to find the number of neutrons, which is called as what, A is equals to this is equals to A minus P is equals to neutrons. So if we subtract the number of protons from the mass number, we can get the number of neutrons each. So this is our A and this is our Z, or we can also write it as A minus, because number of protons is also equals to the mass atomic number, that is equals to number of neutrons. So if we just subtract these two, we are getting a number of neutrons. So in case of carbon, if we subtract 14 minus 6, we are getting as 8. In this case of nitrogen, if we are subtracting 7 minus 7 out of 15, we are getting as 8. If we subtract 8 from 16, again we are getting as 8. So these 3 atoms have the same number of neutrons. Therefore, these 3 atoms are called as isotones to one another. So these 3 atoms, that is carbon 614, nitrogen 715 and oxygen 1618, are termed as isotones to one another. The next is the drawbacks of the Rutherford model of atom, because these terms are derived from the Rutherford model of atom as an achievement of Rutherford model atom, but along with the achievement there is some drawbacks of Rutherford model of atom. As the Rutherford model of Rutherford states that the electrons are revolving around the nucleus in fixed path known as orbits. So if the electrons are revolving, though they must possess some energy, and if the energy is emitting in case of radiation, so there may be the decreased energy, and after some time the electron will put down in the nucleus. So due to continuous motion of electrons around the nucleus, it will result in the emission of radiation. and as the emission of addition is taking place, it will continue to shrink the path of orbit of the electron, because as for example, if this electron is revolving around the nucleus in this way, if the energy is decreasing, so it may fall down to the nucleus after some time. So it tells us that there is slowly shrinkage of the orbits of the atom, which will not able to describe the stability of the atom. This is the drawback of the Rutherford model of atom, that it does not tell us about the stability of atom as the electrons is revolving around the nucleus in an orbit. The second drawback of the Rutherford model of atom is that this model does not explain the electronic structure of the atom. Means it does not tell us about the presence of number of electrons in each orbit around the nucleus. Means it does not tell us in first orbit how many electrons are present, or in second orbit, in third orbit, means successively the number of orbits having how many number of electrons are present. It is not explained by this Rutherford model atom, and these drawbacks can be cleared by the next model atom that we will study earlier, that is Bohr model atom. So this is the drawbacks of Rutherford model of atom. So if you like this video, please like, share, and if you have any doubt, just ask in the comment box. Thank you so much.